Wait, I have a question for you. What if I told you that the technology considered most advanced in cars today is actually the result of a 50-year-old mistake? Would you believe me? Probably not. And what if I also told you that the country that fixed that mistake was not Silicon Valley, was not Germany, was not Japan? It was the country the world spent decades calling a copycat. That is what this story is about. Because the 10-speed gearbox is not just a story about gears. It is a story about a way of thinking that told us more always means better. And by the time the rest of the world figured out that thinking was wrong, China had already changed the game. Let us start with the real problem. The engine sitting inside most cars on the road today, the petrol or diesel engine, sounds powerful. And it is. But it is also surprisingly fragile in one very specific way. This engine has a comfort zone, a narrow RPM range where it works best, roughly between 2,000 and 3,000 RPM. RPM means how fast the engine is spinning. Drop below that range and the engine struggles, it stalls, it loses power. Push above that range and you get heat, wear, and terrible fuel efficiency. Now think about what a car actually has to do. One moment, you're crawling through city traffic at 10 kilometers per hour. The next, you're cruising on a highway at 120. The engine needs to power both situations, but its comfort zone stays the same. So how do you keep the engine in that narrow sweet spot across such a wide range of speeds? That is the question that created the gearbox. The gearbox had one job: keep the engine happy. Low speed meant a small gear ratio. High speed meant a large gear ratio. Whatever the car was doing, the gearbox made sure the engine stayed in its comfortable zone. In the 1970s, 3 gears were enough. By the 1980s, 4 became standard. The 1990s brought 5-speed gearboxes to most cars. And then came the 2000s. Emission laws got stricter around the world. Fuel economy standards tightened. Car companies needed their engines to be more efficient. And so they made a decision, one that looked brilliant on paper and turned out to be a very expensive mistake in the real world. The theory was simple. More gears mean the engine stays closer to its perfect RPM at every speed. More time in the sweet zone means less fuel burned. Less fuel burned means lower emissions. Lower emissions means passing the regulations. From that logic came 8-speed gearboxes, then 9-speed, and then the centerpiece of this whole story, the 10-speed automatic transmission. Ford and General Motors developed one together. It was called a breakthrough. Automotive journalists praised it. Engineers called it a masterpiece of modern design. But the people who actually drove those cars every day, they had a different experience. Let me tell you what's actually inside a 10-speed gearbox. 4 planetary gear sets, 6 clutch packs, hundreds of individual oil passages, dozens of sensors and solenoids, all of them working together every single second to figure out which gear is the right one right now. And this is where theory and reality start pulling in opposite directions. Picture this. You're driving at 50 kilometers per hour. You press the accelerator, just a little. In that one moment, the gearbox runs a calculation. Is 6th gear right? Should it drop to 5th or hold in 7th and wait? That calculation takes a fraction of a second, but you feel it. That tiny hesitation, that moment where your foot presses down and the car takes just a beat too long to respond. We spent years calling that refinement. We thought it was smooth, sophisticated shifting, but it was inefficiency. Every gear change wastes energy. Every moving part creates friction. The system built to save fuel was burning fuel just to operate itself. And reliability was a problem too. More parts means more things that can fail. One small sensor goes bad in a 10-speed gearbox, one solenoid stops working, and the entire car goes into limp mode. Repair is expensive, and if the gearbox itself fails completely, there's no fixing it. You replace it, and replacement costs can run into thousands of dollars. Sometimes the cost approaches what you paid for an older used car. That was the truth nobody put in the brochure. Meanwhile, on the other side of the world, a different kind of thinking was developing. In China, Chinese engineers asked a question that nobody else had seriously asked. Why are we connecting the engine to the wheels at all? Now that sounds simple, almost too simple. But the answer to that question and the courage to act on that answer, that's what shook the entire industry. For 100 years, every automotive engineer assumed one thing: the engine's job is to drive the wheels. The gearbox existed entirely because of that assumption. China said, that assumption is wrong. The engine's job is to make electricity. The electric motor drives the wheels. That one shift in thinking changed everything that came after it. This system is called DHT, Dedicated Hybrid Transmission, and understanding how it works is where this whole story comes together. When you're driving in the city, in traffic, stopping at signals, moving slowly through streets, during all of that time, the engine is completely disconnected from the wheels. Completely. The engine has only one job in that moment: generate electricity. It burns fuel, spins a generator, and produces electrical power. That electricity goes to an electric motor, and that electric motor turns the wheels. Now here's the physics that makes this so important. An electric motor has a unique property. It produces maximum torque at 0 RPM, which means when the motor is completely still, when the car is sitting at a red light, the moment you press the accelerator, the motor delivers full power instantly. No gear shift, no clutch engagement, no hesitation. Just immediate, smooth, continuous force. That feeling of instant response, that seamless surge of acceleration, that's what people feel the first time they drive a modern electric or hybrid car and can't quite explain why it feels so different. And that's something the traditional internal combustion engine with 4 gears or with 10 could never fully achieve. But the real genius of this system goes one layer deeper. Because now that the engine is no longer directly connected to the wheels, engineers got a freedom they never had before. The engine no longer needs to perform across every possible speed and load. It has one purpose: make electricity. So engineers redesigned it around that single purpose. They optimized it for one narrow RPM range where its efficiency is highest. Techniques like the Miller cycle were applied. The internal components were tuned specifically for steady-state, high-efficiency operation. The result is an engine that never gets overworked, never sits at an inefficient part of its operating range. It stays in its ideal zone, quietly and steadily producing electricity. And you, the driver, experience the electric motor's instant, smooth power up front. You get the best of both. This is what engineers call series hybrid mode, and in city driving, cars running this system consistently use 30 to 40% less fuel than equivalent cars with traditional transmissions. Not in a lab, in real-world driving conditions. Now, here's an objection that comes up often. What about the highway? When you're cruising at steady 80 or 100 kilometers per hour, converting mechanical energy to electricity and then back to mechanical energy creates conversion losses. That's a real and fair point. And in 2015, it was a genuine limitation of early hybrid systems. In 2026, it's a myth that the technology has already moved past, because DHT includes a direct drive mode. When the system detects you're at a stable highway speed, a clutch engages. The engine connects directly to the wheels. No electricity conversion, no generator in the middle, just one carefully chosen gear ratio that lets the engine cruise at a calm and efficient RPM. Conversion losses drop to 0. Efficiency is at maximum. And when you need sudden power to overtake a truck, to climb a steep hill, to respond to something unexpected, the electric motor assists instantly. No lag, no waiting for a downshift. You get engine efficiency for steady cruising and electric motor responsiveness whenever you need it. City driving, electric smoothness. Highway, direct engine efficiency. Both worlds together, seamlessly. This is what the automotive industry had been promising for decades. China is the one that actually delivered it. Now let's talk about money, because that's where every technology debate eventually lands. A 10-speed gearbox is a maintenance challenge. Transmission fluid needs changing at regular intervals. Clutch packs wear down over time. Sensors and solenoids fail. Complex systems fail in complex ways, and when a 10-speed transmission fails completely, as many of them do at the 100,000-kilometer mark, you're not repairing it, you're replacing it. In a mid-size American truck or SUV, that can mean anywhere from $2,000 to $4,000 just for the transmission, labor on top of that. Now compare that to a DHT hybrid system. Fewer moving parts means fewer things that can break. The engine runs at a narrower, more consistent operating range, which reduces wear significantly. The electric motor has almost no maintenance requirements, no oil, no clutch wear. Its operational lifespan is essentially the lifespan of the car. Long-term, a well-designed DHT system is both more reliable and cheaper to own than a traditional multi-speed automatic. And that economic argument, that technology, wins in the market. Not the spec sheet, not the engineering awards, the total cost to own and operate over a decade. Let us zoom out now and look at the bigger picture. Because this is not just a story about one transmission system versus another. This is a story about how industries get trapped. Western car companies had the resources to solve this problem. They had engineering talent, research budgets, and decades of transmission experience. Ford and GM had some of the best powertrain engineers in the world. So why did they end up building increasingly complicated gearboxes instead of questioning whether gearboxes were even the right answer? Because they could not challenge their own assumption. For 100 years, the entire industry had been built on one idea. Engine drives wheels. Every improvement, every innovation, every engineering talent in every lab was pointed in the same direction, making that connection work better. 4 gears to 6, 6 to 8, 8 to 10. Every step was incremental. Every step was standing on the same foundation. Nobody stopped to ask whether the foundation itself was wrong. China came to the automotive industry relatively recently. They did not have 100 years of sunk cost in the traditional approach. They did not have factories full of machines optimized for building conventional transmissions. They did not have decades of engineering culture built around making the existing system work better. They looked at the problem fresh, and a fresh set of eyes asked the obvious question that everyone else had been too invested to ask. Why is the engine connected to the wheels? This pattern shows up everywhere in technology history. Phone manufacturers kept adding more buttons, more features, more complexity to physical keypads, until Apple asked whether a keypad was necessary at all. Camera makers kept adding more dials, more manual controls, more mechanical complexity, until computational photography made most of that complexity irrelevant. In every case, the incumbent industry was optimizing within an assumption, and the disruptor was the one who questioned the assumption itself. The 10-speed gearbox was the apex of one era of thinking. It was the most refined version of an idea that had been improving for 50 years. And that is often exactly when a technology is most vulnerable. Because the more refined an existing solution gets, the harder it becomes to see that the entire approach might be wrong. The numbers tell the story clearly now. In 2024, China sold more electric and hybrid vehicles than any other country in the world. Not because the government forced people to buy them, but because consumers looked at the fuel savings, the lower maintenance costs, and the genuinely better driving experience, and made the rational choice. 1 in 3 new cars sold in China in 2024 was either fully electric or a plug-in hybrid. That ratio is only moving in one direction. And Chinese automakers are now exporting these systems globally. BYD, Chery, Geely, Li Auto. These names were unknown in most of the world 5 years ago. Today, they are expanding into Europe, Southeast Asia, South America, and the Middle East, not by competing on price alone, by competing on genuine engineering quality. The technology that was dismissed as Chinese cost-cutting turned out to be the most efficient powertrain architecture in the consumer automotive market. So the next time you're at a car dealership and a salesperson proudly tells you, "This truck has a 10-speed automatic transmission," smile, because now you know what that actually means. It means the technology peaked. It means engineers built the most complex possible version of an idea that was fundamentally limited. And it means the world has already moved on. The gearbox did not fail. It became irrelevant. And that is technology's harshest verdict. You do not have to break down to lose. You just have to stop being necessary. The lesson here is bigger than cars. Technology does not evolve by adding complexity. It evolves when someone has the courage to remove what was never actually necessary in the first place. The future is almost always simpler than the present, not more complicated. Simpler. If you found this story valuable, subscribe to the channel, because next time we're going to break apart another technology myth that you've never thought to question. The future is always simpler than you think.